Welcome back everyone. This is part 2 of our chemical bonding series. Today we will be discussing about Lewis symbols and Lewis structures. So without further ado, let's begin. We have already learned that valence electrons are involved in chemical bonding. What are valence electrons? Electrons present in the outermost shell of an atom are called valence electrons. And how can we represent these valence electrons? G.N. Lewis, an American scientist, introduced a symbol notation to represent valence electrons. In this method, valence electrons are represented as dots around the symbol of an atom. And this method is called Lewis symbols. Let us try to write the Lewis symbol of carbon. Carbon atomic number is 6 and its electronic configuration is 2,4. 2 electrons in the first shell K shell and 4 electrons in the valence shell L shell. So in the case of carbon there are 4 valence electrons. So the Lewis symbol for carbon can be written like this. First write the symbol of carbon and put 4 dots around it. Okay. Now we can write the Lewis symbol for sodium. Sodium, you know that the atomic number is 11 and its electronic configuration is 281. So there is only one electron, valence electron in the case of sodium. So the Lewis symbol for sodium can be written like this. Na with 1 dot. Similarly, we can write the Lewis symbols for S block and P block elements. Please note this point that we do not write Lewis symbols for D block and F block elements because they do not follow octet. Okay. So here you can see the Lewis symbols of elements of the second period. The second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Here the number of dots indicates the number of valence electrons. In the case of lithium only one valence electron, so there is only 1 dot. Similarly, if you take boron, there is only 3 dots. That means there are 3 valence electrons in the case of boron. If we take fluorine, you can see 7 dots. That means there are 7 valence electrons in the case of fluorine. Now we are going to see what are the significance of Lewis symbols. Lewis symbols can be used to calculate the valency of an element. What is meant by valency? Valency is the combining capacity. The valency of an element is equal to the number of dots in Lewis symbol or 8 minus number of dots or valence electrons. For example, in the case of elements of second period, for elements lithium, beryllium, boron and carbon, valency is equal to 1, 2, 3, 4 respectively. That is, valency is equal to the number of dots. Okay. For elements nitrogen, oxygen, fluorine and neon, valency is equal to 8 minus number of dot, that is 3, 2, 1, 0 respectively. So here valency is equal to 8 minus number of dots. Number of dot means number of valence electrons. So in this way we can calculate the valency of an an element using the Lewis symbol. So here also remember one thing. The valency remains the same in a group. Why? In a group, all the elements have similar outer electronic configuration. For example, if we take group 1, there is only one valence electron for all the elements in group 1. So their valency becomes 1. So the group valency also 1. Similarly, if we take 17th group, there are 7 valence electrons for all the elements of this 17th group. So they have valency 8 minus 7 equal to 1, or the group valency also becomes 1. Okay. So by knowing the Lewis symbol, we can calculate the common valency of an element or the group valency. Then now the second thing is Lewis symbols can be used to illustrate the formation of ions from their atoms. For example, take sodium. Sodium, we have written the Lewis symbol for sodium. It is Na with 1 dot because its electronic configuration is 281 and there is only one valence electron. So the Lewis symbol consists of only 1 dot around the symbol of sodium. So in order to attain the stable octet electronic configuration, this sodium atom loses one electron and become a positively charged ion, means a cation. So this cation have electronic configuration 2A and it is the stable octet electronic configuration. Then take chlorine. You know that chlorine atomic number is 17 and its electronic configuration is 287. So there are 7 valence electrons and 7 valence electrons can be shown like this with 7 dots. So in order to attain the octet electronic configuration, this chlorine atom accepts one electron and become a chloride ion. And this chloride ion has 8 electrons. So the electronic configuration becomes 288, the stable octet electronic configuration. This is chloride anion. So in this way we can use the Lewis symbol to illustrate the formation of anion or cation from their respective atoms. Now we are going to discuss about Lewis electron dot structure. What are Lewis electron dot structures? Lewis electron dot structures are diagrams that represent the valence electrons of atoms within a molecule. Let us try to draw the Lewis electron dot structure or simply Lewis structure for chlorine molecule. It is formed by the combination of 2 chlorine atoms. You can write the Lewis symbol for a chlorine atom like this, chlorine with 7 dots. Two chlorine atoms with 7 valence electrons share a pair of electrons and forms a single covalent bond between them, forming a chlorine molecule. So the Lewis structure for chlorine molecule can be written like this. or with a single bond between them. So this single bond contains 2 electrons which are shared between these 2 atoms. And this shared pair of electrons are called bond pair. And we can see here electrons which do not take part in chemical bonding, and these electron pairs are called lone pairs. So in a chlorine molecule, there are 3 lone pairs around each chlorine atoms. Now let us try to draw one more Lewis structure for oxygen molecule. An oxygen molecule is formed from 2 oxygen atoms with 6 valence electrons. So we can draw the Lewis symbol for an oxygen atom like this. So 2 oxygen atoms with 6 valence electrons share 2 pairs of electrons between them and forms a double bond between the 2 oxygen atoms. So the Lewis structure for an oxygen molecule can be drawn like this. First pair of electrons forms a single bond and the second pair of electrons form a double bond. So here also you can see 2 pairs of electrons which do not take part in chemical bonding around each oxygen atom. Now what are the steps to write the Lewis structures of simple molecules? The first step is to count the total number of valence electrons of the combining atoms. With one example it will be clear to you. So let me take NF3 as an example. Okay, so here you can see nitrogen and 3 fluorine atoms as combining atoms. So the first step to write the Lewis structure for this molecule is to count the total number of valence electrons. Here nitrogen has 5 valence electrons and fluorine has 7 valence electrons, so 7 into 3. So total we have 5 plus 21, that is equal to 26 valence electrons. Okay. Now the second step is write the skeletal structure of the molecule. So here please note one point. If there are more than 2 atoms, you have to take the least electronegative atom as the central atom and put other atoms in the terminal positions. So here nitrogen is least electronegative than fluorine, so nitrogen should be the central one and you put the fluorine atoms in the terminal positions. And now put the valence electrons as dots. So fluorine has 7 valence electrons, so 7 dots. Nitrogen has 5 valence electrons, so we can show the 5 valence electrons as 5 dots. Okay. Now the third step is draw single bond between the atoms and check octet is satisfied for the combining atoms. So again write nitrogen and fluorine in terminal position. So draw single bond between the combining atoms. So here there will be 3 single bonds. A single bond means 2 electrons. Okay. Here also 2 electrons, 2 electrons. And now check whether these atoms are satisfied with stable octet electronic configuration. First take the nitrogen atom, central one. Check for complete octet. So we can see here nitrogen has 2 electrons, so 2 plus 2 plus 2, 6 electrons, and here there is one pair of lone pair electrons. So total there will be 8 electrons for nitrogen after bonding. So octet is satisfied. Now check for fluorine atoms. So here fluorine gets 2 electrons from the single bond. So 2 plus there will be 3 lone pairs. So 6 plus 2, that is 8 valence electrons for fluorine atoms. So octet is satisfied for this one also. So here also we can see the octet is satisfied. Here also the octet is satisfied. Okay, so now the third step is completed. The fourth step is, if octet is not satisfied, make multiple bond with the available valence electrons and the remaining electrons, if any, may exist as lone pairs. In the case of NF3, no need to make multiple bonds. Okay, with single bond itself the octet is satisfied and the remaining electrons remain as lone pairs. Okay, so in this way, using these steps, we can write the Lewis structures of simple molecules very easily. I hope this video was helpful to you. If you like it, please give it a like and share with your friends. More videos will be uploaded soon. Till then, take care of yourself. Bye.